Okay, this is where we last one ran out. Remember, these videos go about 15 minutes, and so that's about all we can get. So we have to stop. So just to kind of clarify, we talked about these diatomic elements we have to watch out for. You can just write them on your periodic table, and so it's not anything strange. Just have them like this, and say, "Hey, these are the diatomic elements." And I've got to watch out for them. Now, if you find yourself doing something like this, putting a 3 next to aluminum, that's automatically going to be wrong. You should not be putting numbers that are not 2s, and you should only be doing it for that very select few elements that are just not stable enough to be alone. Okay, so now let's talk about balancing. We're going to look at balancing here in a minute, but one of the goals that we're going to try to do is we are going to try to make both sides of the arrow the same. So think of it like you have a right side and a left side. Those need to be the same. So you can kind of think of the arrow as an equal sign, all right? So right now, see there's one aluminum and 3 bromines on the right. And then over on the left, there's 1 aluminum and 2 bromines. And so the bromines are not equal. And that's going to turn out to be a problem for us here in the very near future. If you look at the second one, I have 1 sodium and 2 chlorines. And over here, I have 1 sodium and 1 chlorine. Again, that's going to be a problem. So our goal moving forward is to take and identify that this side does not equal this side and that that's going to be a problem. And we're going to be able to fix that, but we want to spot that, hey, these chemicals, starting chemicals, do not match these ending chemicals. So we're going to want to fix that. Okay, so that's what we're going to be doing as we kind of progress through this. So we're learning to build out the equations, and then we're going to be making sure that the left and the right side are the same. All right, so let's go back over to our, like I said, it's kind of hard going back and forth on the Chromebook here. So there's our diatomics. We'll kind of start here. There's that refresher. Hopefully you got all those notes down. Diatomics, the bromine, the chlorine, they needed a little bit of help. The Brinkelhoff. So have all that down. And once again, that Brinkelhoff really does help. Now, memorizing them just by memorizing kind of something kind of silly, I think usually works out pretty well. So, okay. I want you to try and do these on your own. All right. So it says, practice writing word equations. It says, attempt to write the skeletal equations for the following word equations. So what is a skeletal equation? It's just writing out the chemical symbols and chemical formulas instead of the sentences, instead of the word equation. Okay. And then we're going to go ahead and take a look and see if you got them right. Okay, so pause the video, go do that. All right, here we go. Let's take a look at where you were so you can kind of see that all of that. But I want to show it to you. We could go over here real quick and want to show you how I'd work through it. Obviously, you can check your answers, but want the thought process. I want you to be thinking, okay, I'm going to do this stuff correctly. So hydrogen and bromine. Okay, so and is a plus. So and is going to be a plus because see they're hydrogen and bromine. React to yield. Okay, react to yield. That means, hey, draw an arrow. Hydrobromic acid. Okay, hate acid. Guys don't like the acids, but you guys should be able to, at this point, at least look them up. If you can't, just Google it, right? Okay, so sodium reacts with, reacts with is a plus, oxygen. So we got some sodium, some oxygen. To form, to form means arrow. So there's the sodium oxide. So let's go ahead and think about it. So hydrogen is a reactant, left side. Bromine's a reactant, left side, arrow. And then this is going to be our product, hydrobromic acid. So same thing down here, reactant, arrow, and a product. Now, you can have multiple chemicals on both sides. It's not always 2 make 1. It could be 2 to 2. It could be 1 to 2. it could be a lot of combinations. So this just happens to be 2 on the left, 1 on the right. That's not consistent. So, okay, hydrogen, H. Okay, bromine, Br. React to yield hydrobromic acid. So if you looked up hydrobromic acid, it is HBr, because bromide takes you back to your rules. Add hydro, add ic acid. So there we go. Now we check for diatomics. So we say, okay, Brinkelhoff. Okay, so Brinkelhoff. There we go. What is in Brinkelhoff? All right, well, hydrogen's in Brinkelhoff. Bromine's in Brinkelhoff. So both of these we need to add a 2. I don't care about Brinkelhoff over here. I care about the fact that hydrogen's +1, bromine's -1, and I crisscross. I don't do anything with Brinkelhoff on that side, right? So let's go down to the bottom one. So let's get a different color of pen. Let's go with the blue. Now let's go back to the green. Sorry. All right, here we go. Solid sodium. Okay, so that's Na. Now they actually went out of their way to say solid, so we probably should put the S here. Reacts with. Okay, reacts with is a plus. Oxygen gas. Okay, so let's go ahead and put oxygen, but let's give it the gas symbol because they went out of their way to tell us that. Arrow. Sodium oxide, which they also said was solid. So NaO +1 here, -2. So I crisscross, and this is what a lot of students forget. They forget to crisscross, and they get things wrong. So we don't want to forget to crisscross. So Na2O. And I'm kind of running out of space here, so I'll put my S for solid right there. Okay, let's check for Brinkelhoff. All right. Is sodium in Brinkelhoff? No. No sodium down here. Sodium, it just stays like that. Is oxygen in Brinkelhoff? Yes, right there. So I got to come in, and I have got to put a little 2 in there. So I'm going to clean up my writing a little bit. Let's put a 2 here, and let's put the gas like that. Okay, so that is our formula. So now, once again, we have this issue that we're going to look at next where these are not what we call balanced, meaning you've got more stuff on one side than the other. So see, we have 2 H's and 2 BRs right here. And on this side, we have 1 H and 1 BR. So we want to think of this as an equal sign, and they are not currently equal. We have to fix that. The bottom one has the same problem. 1 Na, 2 O's, 2 NAs, 1 O. So we gotta fix that. We're gonna show you that next. That's called balancing. But I always start out with writing out these equations because that's what we just learned. We just learned how to name. And so now we're going to go through and learn these. Now, once again, this diatomic thing is usually what poses us the most difficulty. All right, so we're going to go on and be looking at these here in a minute. So let me go back to the notes for a minute. We've got our answers right there. And I went ahead and balanced these. And so it says, notice numbers added in front of the elements or compounds. These are called coefficients. And this process is called balancing. That's what we're building up to. So I said I put a 2 on the right side for the HBr. So now there's 2 H's and 2 bromines on both left and right. So that's what we call balanced. And then the sodium, I put a 4 there, which gave me 4 sodiums on the left. And then I put a 2 in front of Na2O, which gave me 4 NAs and then 2 O's. Because what happens when we put a number in front, it multiplies through. Just like in math, it basically distributes among the elements. So it's 2 times 2 for sodium and 2 times 1 for oxygen. But we're going to look at that as we kind of keep on going here. So here we go. Chemical equations, learning to balance. We got things on the left side. Those are reactants. We got things on the right side. Those are products. And then we want everything to be the same. Now, it can be in new combinations. You can form different stuff, but we have to have the same things at the end. as at the beginning. So the building blocks that we start with are the things that we have at the end. So if you look at that picture, there are 4 white chemicals. Those are the hydrogens on the left. And then look at the right. There's also 2 and 2. So that's 4. So what happened is they just rearranged themselves, but they still have the same amount of hydrogen on both sides. If you look at the black atom that's in the methane molecule, the black atom there for carbon is now in the carbon dioxide on the right, but still just one black atom on both sides. And then the red atoms, those are the oxygens. They're together on the left, so we have sets. So 1, 2, 3, 4. But on the right, they've moved around and have new partners, but it's still 4 red atoms. And so it's balanced, and we're going to be working towards that as we move forward. All right. So here we go. Definition, law of conservation of mass. It says the law states that matter or mass or matter, or think atoms in this case, cannot be created or destroyed. We cannot get rid of them. We cannot create them. We just move them around and create different combinations. So it says if you're going to build a Lego Death Star on the right, you need to start and end with the same pieces. So all the pieces you get in a box, you need them all to complete the Death Star. So it's not like you build it and you, if you're missing pieces, you don't build it. And so whatever you start with, you use and you end with. So our starting materials, we put them together, and they're the ending materials. Now we could tear that Death Star up and we can make something totally different using all of those pieces. It could look totally different, but we would use all the same pieces. That's the idea of balancing. The things we start with are the things we end with. All right, I can't give you an empty box and then suddenly you have a Lego Death Star. You have to have the pieces to build it. So it says, does this equation below follow the law of conservation of mass? The idea is the stuff on the left is identical to the stuff on the right, just maybe moved around. So the same number of items, just in different combinations. So if we look, we've got 2 H's on the left. Water has 2 H's. But on the right, look, we've got glucose has 12, not balanced. We've got 3 O's on the left. There's 1 in water and 2 in the carbon dioxide. So that's 3 O's. On the right, there's 8 O's, not balanced. And then there's only 1 carbon on the left in that carbon dioxide. And then there's 6 in that glucose. So it's not balanced. So the answer is no. That formula is not following the law of conservation of mass, so we would have to balance it. We would have to do a little work. So this is balancing. So balancing means we get to put numbers in front, and that is the only place you get to put a number. You don't get to put a number below. You can't change the subscripts. You can't have fractions. We're not going to write out ones, and you got to reduce if possible. So the key thing that students struggle with is that the only place you can put something is in front. If you mess with those little numbers, the ones that are blue, the subscripts, you are changing the chemical into something different. So like if you change the 2 in the H2O and you make it like a 3, then you turn it into, H3O is going to be, you're going to be turning it into a hydronium, which is not water. If you put a 2 in the back of the oxygen, make it H2O2, you turn it into hydrogen peroxide. So we can't change the little numbers. They have to stay the same. We only get to fiddle with the numbers in front, the red numbers. We call those coefficients. And so what happened here, put a couple of coefficients in, and now you have 4 H's on both sides and 2 O's on both sides. Remember that number multiplies. Just like in math, it kind of distributes. So we're going to work some practice problems, and you guys will start to see. So I am going to pause it here, and we will get back to it in a minute.